Hello friends, welcome to you in this video lecture on mechanisms with some special features. This is lecture number 4 under the subject Theory of Mechanisms and Machines. This lecture is specially designed for the GATE aspirants of mechanical engineering and the students of mechanical engineering having 4-year semester course will also be benefited by this lecture. Let us start with straight line mechanism. In straight line mechanism, a point on floating link generates a straight line. So what is floating link? Floating link is a link which is not connected to a fixed link. So a point on floating link will generate a straight line. Now all of we know that a straight line can be a straight line, we get straight line motion with a prismatic pair. But a prismatic pair do not generate a straight line. Rather, it copies the straight line. Now, at the old times, when milling machines were not developed, at that time, to generate a slot or to manufacture a rectangular slot with high accuracy was impossible. So the objective of engineers was to develop such a mechanism with revolute pair which generates a straight line. Now straight line mechanism can be divided into two groups. One is approximate straight line mechanism and second one is exact straight line mechanism. In approximate straight line mechanism, the complete path of the point which generates the straight line is not a straight line. Rather, a portion of the path is a straight line. So in approximate straight line mechanism, a portion of the path is straight line. Whether in exact straight line mechanism, the entire path is a straight line. The entire path of the point on floating link is a straight line. So let us start with approximate straight lines. So what are the common examples? The first example is Watt's mechanism. It was used to guide the piston of early steam engines. Watt first invent an approximate straight line mechanism. So Watt's mechanism is an approximate straight line mechanism. So this is the kinematic diagram of Watt's mechanism. It is a 4-link mechanism. Link number 1 is fixed. This is link number 2 or crank. This is the floating link, coupler. AB is the floating link because AB is not connected to any fixed link. So AB is the floating link and O4B is the follower. Now let us see the animation of a Watt's mechanism. So the yellow color link is the floating link or the coupler. So midpoint of the yellow color link, that is AB, is generating a straight line between small c1 and c2. The entire path is not a straight line. This is a curve. At this portion, this is a curve, and this portion, only this becomes straight line. So small c1 and c2, within this range, it maintains the straight line, not enter the path. That's why it is an approximate straight line mechanism. The other examples are Evans mechanism, Roberts mechanism, and Chebyshev's mechanism. I am not going to detail of this. So Watt's mechanism is an approximate straight line mechanism. Now let us come to exact straight line mechanism. That is, the point on floating link will generate a straight line entire of its path. So the first example is Scott-Russell mechanism, but it contains a prismatic pair. This is the kinematic diagram of a Scott-Russell mechanism. This is a 4-link mechanism. Link 1 is fixed. This is link 2, O2A. BC is link number 3 and the slider is link number 4. Now the point C on the link BC will generate an exact straight line. So enter the path of C is straight line. So let us see the animation. So the yellow color link is link BC, red color link is O2A, and the end point is C, which is generating a straight line, and this is a prismatic pair. The green one is a prismatic pair that is connected with 1, that is the blue link, and 4 is the slider. So green color is the link number 4, yellow color link is BC, and at the end point of C was generating a straight line. But Scott-Russell mechanism contains one prismatic pair. Next one is Poiseuille straight line mechanism, which contains only revolute pairs. This is the exact straight line mechanism only with revolute pairs. So let us see the kinematic diagram. This is a Poiseuille straight line mechanism. This is a 8-link mechanism, out of which one is the fixed link, that is O2O4. Link number O2A and O2B, that is link 2 or 3, are in equal length. Link 1, that is O2O4, and link number 4, that is O4P, are also in same length. And APBQ generates a rhombus. This is a rhombus. So length of link 5, 6, 7 and 8 are equal, where point Q will generate an exact straight line. Let us see the animation. This is Poiseuille straight line mechanism. The blue link is the fixed link O4O2. Blue link is the fixed link. Yellow color links are O2A and O2B. Red color link is O4B, and point Q is generating a straight line. Point Q is generating an exact straight line because enter the path is a straight line. The next one is hard straight line mechanism, which also contain only revolute pairs. I am not showing this in details. Just remember the name hard straight line mechanism. Now let us come to a mechanism which generates intermittent motion, that is Geneva mechanism. So this is a Geneva mechanism. This is the crank which contains a pin, and this is called Geneva wheel, on which 4 slots are made. This is the Geneva wheel. It is a cam-like mechanism in which the constant rotation of the crank generates intermittent rotary motion of the Geneva wheel. So this is the crank which is rotating at a constant speed, and it produces intermittent rotary motion of the Geneva wheel. Let us see the animation. So this is a Geneva mechanism. This is the crank, and this is the pin made on the crank, and this is the white one is the Geneva wheel. So constant rotation of the crank produces an intermittent rotary motion of the Geneva wheel. Constant or uniform rotation of the crank generates an intermittent rotary motion of the Geneva wheel. Now let us come to copying mechanism. That is a pantograph. A pantograph is a copying mechanism. What is that? This is the kinematic diagram of a pantograph or copying mechanism. This is a 5-link mechanism. Link 1 is fixed, link 2 O2B, link 3 O2C, AQ is link number 4 and AP is link number 5. If point P traces a map, then point Q will copy the same map. If point P traces a map, then point Q will copy the same map at a smaller or larger size. That depends on the link length. That is AP and AQ. So let us see the animation. So this is the pantograph mechanism. This point is tracing a triangle, and the point at this end is copying the same at a smaller size because link length of BC is less than BE. Ignore the notation here. The notation on kinematic diagram and animation are not same, but say point E is P and point Q is C. So at this end, point traces a triangle, and at this end it is copying the same at a smaller size. So we have completed our lecture. Thank you for watching this video. I wish you best of luck in your GATE examination. Jai Hind.